Hi everyone, this lesson is going to show you how to take a derivative of a function using first principles. So this is our task. We have this function, so y equals f of x defined as x squared plus 3. Now the first step in first principles is to recall the rule. So we say dy dx equals the limit as h approaches 0 of f of x plus h minus f of x divided by h. So we have to do some substitutions here. Limit as h approaches 0, we have to keep writing this. Now, if I was to substitute the value x plus h into this expression, then where there is an x would be replaced with an x plus h. So that's the function, but instead of x, we have x plus h instead. Still with squared, still with plus 3. Now I have to subtract f of x. Now f of x is x squared plus 3. Now the way I've written that there is potentially going to make us get it wrong, because I've said subtract x squared plus 3. In fact, it's subtract all of that. It is subtract the entire function of x. So I recommend you use brackets on that at that stage when we subtract f of x. Now we'll expand x plus h squared. This will give us x squared plus 2x h plus h squared. Then I'm up to plus 3. Then by distributing this negative sign I have minus x squared minus 3, all still divided by h. At this stage, if everything's working, I should find some things that will be equal and opposite. So I have x squared subtract x squared, I have positive 3 subtract negative 3. And I'm left then with the limit as h approaches 0. Now there's only two terms left, and I note that both of them have h as a common factor. So I will write this as 2x plus h. Now I've taken a common factor of h, and there's still an h in the denominator. They will now cancel. At this point, I can substitute the value to evaluate my limit. If I was to try and evaluate the limit before this, I would have ended up with a divide by 0 catastrophe. I don't want that. But now I can substitute 0, and my expression simply becomes 2x. And remember, this was the derivative, dy dx. Sometimes that's also written as f dashed x. So there's the alternates. Sometimes it's also written just as y dashed. So there's three different ways that we can write the derivative. All of those things, y dashed, f dashed of x and dy dx, mean the same thing. They mean the derivative. And in our case, we started with this function here, and we ended the derivative of that function is this. We used that process there. That process is called first principles. Now, we were supposed to find the slope of the function when x equaled 1. To do that, we substitute. So we write dy dx. Now some people put x equals 1 here, and so our function is 2 times x. Well, we gave x was 1, so that's just 2, isn't it? Now I'll show you what I mean with my graphing calculator. So let me get that here for you to see. There it is. So if I were to go to, actually I'll start from here. On this main screen, if I press the options key, then this is short for calculus, and of course derivatives are part of calculus. Here's the key for taking a derivative. It doesn't look quite the same as we had. Now what I need to do here is write my function. From memory, I think my function was x squared plus 3, wasn't it? And I'm evaluating when x equaled 1. So there it is. That's the answer we had. We had the answer 2, didn't we? Yes, we did. So this has, it's not saying dy over dx, because that's what y equaled, isn't it? We started with y equaled x squared plus 3. And we were using 1 to evaluate. If I was evaluating at a different location, I'd get a different value, but the derivative function would still be, the derivative would still be 2 times x. If x changes, then it evaluates to a different number, that's all. Now let's look on the graphing screen. So I've entered my function here, and I can draw that. We shouldn't be surprised to see that it's a parabola because of the x squared term, and we shouldn't be surprised to see that the turning point is shifted vertically by 3. That's the effect of the plus 3 at the end. Now what I want to do though, I was interested in the point where x was 1, so that's that point there. I can use the trace function, and I can move across to get to that point. There it is, x is 1, y is 4. I think if I hit the enter key, it leaves a little dot there. Do you notice that I've got my calculator here set to show the derivative? The derivative at that point equals 2. That's what we thought it did. I can control that from the setup menu. When I'm on the setup menu here in the graphs, I can have derivative on or off. If I set derivative off, don't know why I'd want to do that, but if I set derivative off, then, and I do a trace function, I no longer have dy dx there showing up for me. So I'll just press enter to get a little dot there. That's good. There's my point of interest. Now if I use the G-solve key, sorry, wrong one. If I use the F4, here we go, did it wrong. If I use the sketch key, F4, sketch, I can ask for tangent with F2. And there's a tangent. Now what I need to do is move that point across to coincide with 1 and 4. There it is. And there's my tangent. That tangent line is the thing that has a gradient of 2. And if I check it out, it seems like from there, that point, I'd move forwards by 1 and up by 2 to get to the next point on the green line. Likewise, I could have gone from there, forward by 1, upwards by 2. That's a gradient of 2 for the tangent, isn't it? Notice that if I put the tangent line, if I put the point of interest at different places, then the gradient of the tangent line changes. That shouldn't be too surprising, because we saw here that the derivative was a function of x, meaning that the value of the derivative changed as the value of x changed. Alright, that should be enough for now. I've shown you how to do a derivative by first principles. We evaluated it when x equaled 1, but we could have picked any other location we liked. And I've shown you how to use your graphing calculator there, and also back here on the Run Matrix app, I've shown you how to check your working by evaluating the derivative at a certain point. Thanks for watching.